All right. So the second important information in the carbon NMR is chemical shift. Okay. So what's chemical shift? Well, chemical shift is the number down here in the unit of ppm. We use delta sign as a short of chemical shift right here. Okay, it's a great symbol. Anyway, the chemical shift. So there's all the theory behind it. We're not gonna get into the detail. We're just gonna focus on how to use or how to read it. Okay, the chemical shift actually tell you the electronic environment around each carbon 13. Right, the carbon 13, which is an isotope of carbon 12, but carbon 12 is actually NMR inactive. So only carbon 13 is NMR active. So we're gonna look just carbon 13. Okay. Anyway, so the basically chemical shift tell you what's around each carbon 13 in the molecules. Okay, and this chemical shift, the number is relative to the chemical shift of 0 ppm of tetramethylsilane. So looks like this. That's tetramethylsilane. So chemical shift of 0. All the chemical shift, all the peaks right here, the location are based off the peak of tetramethylsilane, TMS. Okay, we have a solvent right here. That's NMR solvent, CdCl3, right, chloroform D. Anyway, all right. So basically, chemical shift tell you what's around each carbon that we're looking at, right? But to better explain chemical shift, I have to talk about this, all right? Electron density, shielding, and deshielding effect. You have to understand this first, all right? All right. Let's start right here. So all atoms, but we're gonna focus on carbon. Of course, you guys know contain some electrons. We have some electron density on each nuclei. Okay, we're going to look at carbon here. So let's say this carbon have that much electron density. Now I'm gonna have you guess. Let's say I put the same carbon with an electron withdrawing groups. Okay, what's going to happen to the electron density of carbon? And the electron withdrawing group I'm talking about is, for example, chlorine, bromine, fluorine, high electronegativity. Okay, so those are electron withdrawing group. Oxygen, high electronegativity. Okay, so what's going to happen to the electron density? Well, by its name, electron withdrawing. So you're going to guess that, okay, from that much electron density, this electron density get pulled away toward electronegative atoms. So you're going to go like this, 1, 2, 3, get pulled, get pulled, get pulled, right? So on the left side, carbon, the one that have higher electron density, we call this carbon is shielded. We call shielding carbon. Okay. On the carbon on the right side, less electron density, that carbon is de-shielded by X. Okay, that's a shielding and de-shielding effect. Right? Shielding. You may ask, hold on, shielding from what? Well, from the external magnetic field. When you put all these molecules in an NMR environment, so we have the NMR instrument has a magnet, right? So all this electron will shield, will protect this carbon from the magnet outside. Okay, and this happened. The shielded carbon show up on the right side. The de-shielded carbon show up on the left side. The right side, there's a term we call upfield. So shielded carbon show up upfield, right? And the de-shielded carbon usually appear downfield, like upfield on the right side and downfield on the left side. Okay, that's pretty much it, right? Electron density and shielding, de-shielding effect. So it depends on electron withdrawing group. So the more electron withdrawing group, the more de-shielded the carbon and show up on the left side, the downfield, basically. All right, give you some example here. Go back to the original molecule, ethyl acetate. Okay, I'm gonna have to show you the effect of shielding, de-shielding in here. All right, we're gonna focus on all this carbon. Start with carbon number 4. All right, carbon number 4 is a little away from oxygen, when oxygen is electronegative atom. So let's say carbon 4, this is inductive effect, right? Carbon 4 have that much electron density. Okay, that much electron density, that distance from oxygen, and show up upfield, really upfield on the right side, the far right. Okay, now I'm going to have you guess. Think with me. Carbon 4, that distance from oxygen, that electron density. Carbon 3 though, should carbon 3 be more should carbon 3 have more electron density or less electron density? It's gonna be less, and the reason is, well, closer to the oxygen, right? Oxygen pull more electron. This inductive effect we have learned before, right? So carbon 3 should have less electron density or become more de-shielded, right? De-shielded, go downfield, right there. There we go. Okay, try one more time. If you don't get it, one more time with me. All right, let's focus on carbon number 2. All right, carbon 2 next to the same oxygen and also next to another oxygen. What do you think? Give me a comment about electron density of carbon 2. Should be higher or lower than carbon 3? Oh, come on, right? 2 oxygen. This carbon here doesn't have much electron density, so become very, very deshielded and show up even more downfield. Here we go, right there. Yeah, so we're really, really positive, electropositive. Now move on to carbon number 1. So carbon number 1 is further away from both oxygen. So now this kind of can't really tell now. So carbon, but for sure, carbon number 1 is more shielded than carbon 2. It's going to be more, or go to the upfield on the right side. And carbon 1 is right there. All right. You may ask, how do you know which carbon 1 or 4 is more shielded or more deshielded? Well, this is kind of hard to tell now. Okay. Anyway, so all right, here's how we communicate. We can say that carbon 3 is more deshielded than carbon 4 and appears more downfield than carbon 4. Right? If you want to focus on carbon 4, you can say this in the opposite way. Carbon 4 is more shielded than carbon 3 and appears more upfield than carbon 3. Okay, so now you can see that there's an effect of the factor that affect electron density, shielded, deshielded, is inductive effect, induction. Okay, but there are a few factors. Take a look down here. These are the factors that actually affect shielding, deshielding effect, electron density, high or low. Right? If you remember from Oreo in the chapter 3, that's, well, similar, but really similar. I try to arrange just like that, so because you have seen that before. But the A is not atom in Oreo, right? But you learned before, so it's anisotropic effect. We will talk about this later. Okay, but resonant effect, inductive effect, orbital effect is still the same in here. All right. All right, let's move on to the next video now. We're going to talk about all the chemical shift that you should know. Okay.